Hello students, today we are going to start new chapter wavefront. In this chapter we shall learn that how light's behavior as a interference and diffraction is explained only when it is treated as a wave. And for this Huygens and Fresnel came forward with a principle which is known as Huygens principle, and they were finally able to explain the phenomena which were not explained earlier on the basis of light taken as a particle or having ray nature. Well, before we start talking about Huygens principle, we will learn what is wavefront. Whenever a wave is flowing through a medium, the particles are forced to vibrate, and locus of all particles having same vibration at any instant of time is known as wavefront of that wave. Well, if you drop a small stone in a still water, what happens? You see that a spherical structure is generated, a curved surface appears on the water surface which advances with time. All the particles lying on that curved surface are having same phase, means their angular displacement are same. Well, to have better understanding about the wavefront, you must know what is phase. It is angular displacement of the particle, and all the particles, the position of all the particles having vibration in same phase is known as wavefront. Wavefront can be a spherical, means when the shape of the wavefront is spherical, we call it a spherical wavefront. When the shape of the wavefront is a plane surface, we call it plane wavefront. So we can have yet other type of wavefronts. Well, now we will talk about the two principles, Huygens principle for waves, for light wave. First is they considered that every point on the wavefront which was originally generated by some source is able to generate new wave that is called secondary wave, and the wave which was originally generated by some source, the wavefront generated by original source is called as primary wavefront. Now, the first principle says that every point on the primary wavefront acts as a source to generate another new wave called secondary wave. The advancement of secondary wave is always along the normal to the tangent drawn at the point of any point of the primary wavefront. Say for example, if we consider a spherical wavefront represented by a curved line ABC, and we consider 3 points on the primary wavefront, point A, B and C, then all these points, we haven't considered other points, but any point on the primary is capable of generating secondary wave. For simplicity, we have considered only 3 points. Now, the new wave which will be generated by the point A on the primary wavefront will advance in a direction along normal to the tangent drawn on the primary wavefront. So this black line is a tangent. A tangent is a line which passes just through one point, which touches the curve at just one point. And a line at 90 degree to the tangent will be the normal. The secondary wavefront will always advance in a direction along normal drawn at the point of primary wavefront. In same fashion, we have another secondary wave moving in given direction and accordingly. That means the wave is well diverging. Now if we consider a plane wavefront, which is represented by, say, a point, this line A, we can name it AB, line AB, and we consider one point which is generating a wavefront. Say this is a wavefront. Now every point on this wavefront, taking A as a center, every point on this wavefront, primary wavefront, so drawn by red line, will generate secondary wavefront, which will move along a direction normal to the primary wavefront. So that means, you see, if we consider 3 points on the primary wavefront, say namely X, Y and Z, each point is generating secondary wavefront which is advancing in a direction such that the ray which was usually collimated moving in parallel direction, like a parallel beam, no longer remains precisely parallel. Now this is evident when we make observation at nano level, but if we make observation at macro level, we do not notice it. So therefore, in true sense, any collimated ray keeps diverging, however small it may be, while it advances from one place to another. Now second principle is the new position of wavefront at any instant, called secondary wavefront, advances in a direction which is always along the direction normal to the tangent drawn on the primary wavefront we have just discussed. So these are the two principles, Huygens principle for light wave, and we shall be using these principles to prove that why light is should be taken as a wave, and that will enable us to explain certain phenomena which was not possible otherwise, like explaining interference and diffraction, etc. That's all for today. Thank you and have a nice day.